All right. What's that?
What is your computer like?
I didn't understand the question.
What is specs on your laptop?
What effect on my laptop?
Specs.
Oh, it's the newest one. It's got 32 gigs of RAM and 6 cores. It's pretty fancy. Yeah. I can make VMs. Yeah, and I can make a lot more VMs faster, which is good. And I can save all the partial ones, which is really important because it makes it a lot easier to do these projects when I can save a whole bunch of VMs. Anyway, so we are here, rapidly coming to the end. Today is chapter 18. There's one more class next time. I'll talk about Hopper, and that's it. And class should be at 1 p.m. next week. They canceled CCDC this week, and I think they delayed it, but I don't think it's happening next week either. I think it's not happening again until January, so this class will not be affected any further. And I've got a couple of minutes. Let me see if there's anything exciting in the news. I think maybe nothing that new. Everything should be due on the last day of class, which is next week. And after that, it's late.
Okay.
Yeah. Good? All right. And however, I have not been taking points off for late projects yet because I can't do it in Canvas, so that's probably going to continue that way. So I guess if you turn it in by the 20th, it'd be all right. All right. Good. Let me see if anything's worth mentioning about the news. I think there was some pretty amazing stuff. This was pretty fun. This is the one I thought that got my attention. I'm generally politically incorrect, and here again, this is the comments by the head of the GCHQ, or somebody important at GCHQ, which is Britain's answer for the NSA, trying to explain why law enforcement needs to get in your cryptography. And for some reason, the security community has locked shields and decided to tell law enforcement that there is no way to let them in cryptography at all. It's mathematically a fact, and they need to just shut up and accept not being able to get in. And this is a very strange position for them to take. That is absolutely not true. And I don't quite know how they got everyone to buy on pretending that is true when it's not true. And he's talking about it here, and I thought he was very reasonable. Other people are trying to find things here to scream and yell about, but he said, you know, there is some value in law enforcement. You can't just lock us out completely. And the fact is, law enforcement has real power. You cannot lock them out. If they have to, they will just pass a law like they did with Kalia, forcing you to give them a back door. There's got to be some way. And if you don't do it, they will make you do it. So I don't quite know where the cryptography community has gotten this idea that they can somehow avoid it entirely and pretend that they can give law enforcement zero access. That is just not realistic. And it would be better to actually plan for it. He mentioned some things like the one plan that came out 10 years ago, the government should have a key escrow system where they have the key to everything on some server somewhere. He said, that's a terrible idea. I mean, it won't go that way. But there are other ways, like what Apple used to do. Most companies used to have a backdoor in every product, so you could go with like a warranty and demand, say, I lost my password, and they had a way in. And Apple did. And they would mail the phone to Apple, and Apple had a backdoor to get the data off the phone and send it back to them with a court order, and they paid a fee. It was only the latest version as Apple locked themselves out of their own stuff, and law enforcement is not happy about that. But it is legal to do that so far in America, but it won't stay legal forever. Anyway, that's an interesting issue that people have. But this is pretty funny. If you buy a Sleep Number bed, it has a microphone in the bed, and it listens to you sleep, and it sends the data back to their server. And they say they're going to use it to like rate the quality of their sleep, but this is like those Amazon Alexas. People just think nothing of putting bugs in their house that are recording audio and even video and sending it to God knows where they're just going to do something like put it in an open Amazon bucket and leak it to the whole world. It's very strange how people pretend to care about privacy until there's the slightest convenience available, and then suddenly they couldn't care less. Anyway, it's like my friends getting DNA tests just for fun, which I'm not. I wouldn't get your DNA tested. Holy cow! Those guys have already shown that they just hand that stuff over to anybody, and that affects not only you but everybody in your family and everybody that'll ever be in your family. I wouldn't be, and you're doing it for the benefit of information that is no better than tea leaves. I saw where they interviewed DNA experts and said, "Have you had this done?" And they said, "Hell no, I never have it done." And they said, "Doesn't it mean anything?" He said, "No, it means absolutely nothing." They have no idea what it means, especially where they say this percent American Indian, this percent Chinese and all that. They're just making that up. Anyway, there will come a time when it means something, but not anytime soon. Anyway, so we're down to code auditing, and if I could figure out how to operate my machine, I would open this thing. I'm having no luck so far. All right, somewhere there's a way to play a slideshow. It's backslash diagonal line. See, I can never remember what that is supposed to convey to me. Okay, option cloverleaf P. There's some better word for these things. All right, if they just made it like A and B buttons, like a game, I could understand. Anyway, all right, so auditing source code is an obvious way to find vulnerabilities for certain kinds of vulnerabilities where you can spot obvious things in the source code. You can just do it with grep. You can just look for patterns in source code, and that would find certain vulnerabilities. There are tools out there to try to make this easier, although pretty disappointing in my experience. Cscope is one that is intended to make it possible to look through a huge code base like the whole Linux kernel. Ctags is another one that creates a tag file and supposedly makes it easier to hunt through large amounts of code. I know Microsoft relied on this pretty much exclusively before Vista, and then they got humiliated in Vista into adding fuzz testing to their testing routine. Microsoft liked it at that time because at least source code auditing, you can say code audit with this procedure and you know when you're done. Whereas something like fuzz testing, you don't know when you're done because it's just random. You can just open a text editor and look for certain patterns of code in there. One thing that helps is text editors can match the brackets. Most every code-oriented text editor can do this now. It's amazing how far you can get just by doing that. There was a CTF I did years ago where they had a 67,000 character file that was in JSFuck, and JSFuck is nothing but punctuation marks, nothing but these brackets. And I was able, and like 500 characters are missing at the end. And you have to figure out what they are, and I was totally able to figure out what they are by just matching the brackets. Anyway, there's a bunch of automated tools. There's one called Splint. This is called static checking, static code analysis. This one seems badly out of date. There are a lot of others, but they're mostly specialized in one language, which of course does make sense. The one in your book was CPP check, and that was very easy to get, very easy to run, and I made a project about it. You can run it. I was amazed at how terrible it is. I tried running it on all the code examples that we've used in our projects to see what it will find. And here's a heap overflow. One of our very early ones, you use malloc to make a couple of things on the heap, and then you use string copy to copy something in without checking the length first. So it's a classic overflow, and it doesn't find it. It finds memory leak, which means you have allocated something, but you didn't free it, which is a performance issue. That will mean it hogs up memory and eventually crashes your machine, but it didn't find the obvious buffer overflow. Whereas even the C compiler will warn you, don't use stir copy. Whatever you're doing, no, don't use stir copy. Anyway, here's the format string, which is what I thought would be the most obvious one for this kind of technique, because you just look at a print statement with a variable and no format statement. How hard is that? You could do that with grep, and it doesn't find it. Nothing's wrong. The only thing you notice is buffer overrun possible for long arguments, which is, I'm shocked at how bad these things are. There's one called Flaw Finder that I found to be much better when I tried it a couple of years ago. It's not in Kali by default, but you can add it. But it is surprising. This seems like it would really be a powerful way to debug your stuff. Now, if somebody, I haven't been a professional developer ever, though. So maybe professional developers have some better tools that I don't know about. If anybody has any information, please let me know. I would like to hope that professional developers are using something that works, maybe something expensive and commercial, but I don't know what it is. These free things seem to be completely worthless as far as I can tell. Anyway, there's different ways to do this. Now, one way is like what those tools are doing. Look for certain kinds of code where you can spot it with just a few lines, like format string error, and that's, of course, going to find some flaws, but you're not going to find vulnerabilities that take more than a few lines to cause the problem. And there's a lot of those. We'll be talking about a lot of examples. Another technique is to read a large portion of code and thoroughly understand it. And this, of course, is what I think most people like to make this casual statement. They used to, at least until 2014, with the Linux heartbeat vulnerability. They said, Linux is more secure because millions of people have audited the code. They say, well, it's millions of people have downloaded the code, but none of them have actually read the code. How much fun is it to read through 1,000 pages of code, understand it, and decide if there's a bug in it? The fact is, that's not a very popular hobby. Amazingly enough, very few people actually do it. That might be nice, but this is a whole lot of work and almost nobody bothers. So this is what most people do. The fact is, even if you were to read all the code and find all the bugs, most of those bugs don't matter because they're not exploitable. For example, there's a print without a format, but the thing that is being printed is automatically generated by another part of the program and it never contains any unexpected stuff, so it doesn't matter. That kind of thing. So what you do typically here is you start with the code where user put in data, and then you just try to watch what happens to that data. And that's really all you worry about because that's the one that's likely to be exploitable. That's what people tend to do. Anyway, here's some classes of vulnerabilities to look for. There's generic logic errors. These are the big one. And I just wrote up the version of this class to teach at Black Hat. And they haven't approved it yet, of course, because the deadline was just yesterday. It'll probably take them a few months to decide whether to approve it. But anyway, what I was thinking is this class, I'm going to start this class with hopefully the explanation of why all these problems exist. The reason why code is vulnerable is extremely simple. The basic reason for all the binary attacks here is that you just have bytes and the computer does not know whether they are text or images or code to execute. They're all the same bytes. It seems to me that if you just made the byte 12 bits long and had 4 bits to specify the type of each byte, you could end a whole lot of these vulnerabilities. I haven't heard anybody make a plan to do that, but that would be one way to go. And anyway, this is another similar higher level version of the same thing, which would apply to the command execution vulnerabilities at the start of this class, is that the fundamental problem in security is that you have one system which then takes input from the user and does something with it and then produces output which it passes on to another system. And the second system doesn't have the context and misinterprets the input. And the problem is these things tend to never get fixed because the one system has one administrator running it who only thinks about internal problems, and this system only has one internal administrator, and it's nobody's job to look across both except upper management. And as far as I can tell, in the tech fields, upper management have not understood how to do their job. And they mostly are just sort of baffled and don't seem to understand that they're the only one looking at the big picture to catch this sort of thing. So anyway, here's one of the many fine examples of this. The Moxie Marlin spike and Dan Kaminsky found out independently, and it was really big, I think around 2008. It turned out that the code that sells certificates on the server side is so old it was written in Pascal. Pascal is essentially a long dead language like Fortran, but there's code sitting around written in Pascal. And Pascal does not store strings with null terminators. Pascal stores strings with the length in the first byte. And I guess strings can't be bigger than 255. So the first byte is the length, then all the bytes after that are the characters, and that's a string. So in Pascal, you can put a 0 in a string and it's perfectly fine. So I can do a perfectly valid string to have starnull.evil.com. And if you buy a HTTPS certificate at a certificate broker, a lot of them are using code written in Pascal. So this is a perfectly valid subdomain. You can have a subdomain like www.evil.com and games.evil.com, and now you can have starnull.evil.com, and the Pascal server has no problem with that string and sells you that certificate. And that becomes the official registered name of your certificate. But your browser was written in C. So when you go to a website, if you go to google.com and I sign it with this certificate, star0.evil.com, your browser will now go 3 steps to verify. It'll say, is it a certificate from a valid certificate authority? And it is. I bought it from real authority and paid for it. Is it in the valid date range? And it's in the valid date range. And then it says that the domain name in the certificate equal the domain name in the browser. And the domain name of the certificate is star followed by null byte, which is the wild card, so it matches anything. And the browser people will say, our browser is working fine. And the certificate authorities will say, our stuff is working fine, but you can destroy everything in the translation. And this is the kind of problem you get a lot, where there's not like an if statement somewhere that's wrong or a number that should be different or a line of code that should be different, but there's a disaster caused by the overall combined system. So the kind of exploits we've attacked a lot in this class are pretty much gone because, of course, this is pretty common knowledge, how to do exploits this way, and the defenses have come in. So all these ones caused by unbounded copy, like string copy, they're still around, but only in old code typically. Not too many people are still doing this because, as you've seen, the GCC will even warn you and say, please don't use stir copy, don't do this. you have to really be pretty stubborn to write new code with these mistakes in it. And so here's Microsoft, these bug reports they've been getting since Windows XP. I think Service Pack 2, they've been getting these reports of vulnerabilities, and they've got a list of all the root cause for things, which I thought was pretty interesting. And what we've done here is stack corruption. And as you can see, that was more than half of all the exploits in 2007. And as Microsoft came out with more defenses like address space layout randomization and Vista and so on, they finally began to really improve this. And now it's down to maybe 5% as of 2013. It might even have fallen after this. Microsoft, as far as I know, has not published a more updated list of this. But I thought it was pretty interesting. The thing that's really grown up is use after free. And that's one thing. I don't have a homework in this class for use after free yet. I found an easy one online, but it was like too easy and didn't even learn much. But we'll talk about it in general terms here. And if I can find some example of a reasonable difficulty, I'd like to add it to the course where you practice doing that, because that is the new hotness, use after free. Just all the real exploits using use after free are just very long and complicated, and all the trivial cases are too trivial. I haven't found a good example in the middle yet. This I thought was very nice. How do people get tasks? Address space layout organization and data execution prevention, because those, as you've seen in this class, pretty much end the classic LF null stack buffer overflow. If you just try to inject code on the stack and then run it, that's what these prevent. And they prevent it pretty well. But here's the techniques people use to get around it. The simplest one is just find a DIL that doesn't have the defenses turned on. This unfortunately remains pretty easy in modern versions of Windows. And the main one is return-oriented programming that we use here. That's the solution. You reuse code that's already sitting there. Now, Microsoft has been talking about function defenses in the latest version of Windows 10. I saw the latest security update, and they were talking about adding a defense to where every DIL has a list of entry points and you're not allowed to enter except at the official entry points. And that would be a pretty good idea, and that might start doing something in return-oriented programming. You have to use a function in its entirety as written. You cannot just use the last 3 instructions in the function. There is no reason to do that. That sounds like a pretty good idea. But anyway, and then there's heap spraying, of course. That gets you around address space layout randomization. Anyway, those are examples. All right, and then there's format strings. Quite easy to find with a code audit, obviously. They say for some reason this frequently happens in logging code. I think that's because if you put it in code that goes out to the user, here let me try and mute people because the automatic mute never works on this thing. If you put it in code that goes out to people, then they'll notice it. But if you put it on some kind of internal logging thing, then they won't. So that's a place, and that's also a place where you might be willing to put up with the unformatted output. So it's the kind of thing you might see. So here's something possibly vulnerable where you're printing something to the log, but of course, probably whatever's going in the log is automatically generated and doesn't contain something that came from the user. Although there are some pretty good examples of log vulnerabilities in weblogs, where you actually log the URL, which really did come from the user. You can actually put code in the URL and do things like execute it and stuff. There are some code injection vulnerabilities that have to do with dumping stuff in the log. But of course, it'll be a lot better to just require you to have a format string every time you print. I don't know why that's so hard. That would seem like a reasonable policy to me. All right, and then there's bounds checking. Let's see if there's a way to trick this thing into getting off the screen. All right, so this is very common. I mentioned in the 123 class when you talk about programming how for some reason C chose to write loops in a very strange way. Programmers think that the natural way to count is to start at 0, which is cruel and pointless to me. There's a long dead language called BASIC where you just start with 1. And that's made sense to me, but that's long dead. Everyone thinks you start with 0 now. So if you have 3 objects, they go 0, 1, and 2. But this means an incredible number of times when you think you're counting something, you're off by 1, and this happens over and over and over, like it happened in Snort. It is pretty embarrassing when security products have serious security holes. One of the big examples is SSH. If you watch the original Matrix movie, they take over a power plant through SSH because when people were using Telnet, they upgraded to SSH, but the early versions of SSH had a buffer overflow, so you were worse off than you were with Telnet. And well, I think one thing was funny, when I started doing Android security, one of the first products to put out an Android app was Nessus. And they put your password in plain text in the app on the phone, and they were so embarrassed they took down the app and never put it back up. It's quite common that, and I know Georgia Weidman wrote the smartphone pen testing framework, and it was all full of vulnerabilities, and she was so embarrassed she took it down and everything. It's very common that people write security products and there's huge problems in security. So here's Snort. It's supposed to be your intrusion detection system, and yet when it takes remote procedure call packets, it reassembles them. And when it reassembles them, it made a really big mistake here. there's a limit to how big it can get. And it takes the length. This is, by the way, exactly the same vulnerability caused the ping of death, the famous one from the 90s. In comes your data. There is some maximum. It takes several packets which might add together. It takes each one of them and checks if the length is bigger than the size, give me a warning. But it doesn't take the total length. It takes the length of each chunk. So if you have multiple chunks that are smaller than the limit and add them together, they get bigger than the limit and you overflow. That's the same thing with the ping of death. Anyway, so that's pretty bad. Another thing that happens a lot is people have loops and loops, and within the loops there are if statements that change things. So it is very easy in such a situation to have some condition under which whatever you're looping on grows in an unexpected way. And that can cause you to be off. And so here's an example in Sendmail. The pre-scan function in the address function, you're looking at an email address, and it's looking for certain characters and integer types. And under certain conditions, it creates something like an error string, which is larger. So certain characters grow when converted and make the length too long. And so the exploit is something like this. You send in an address with these special characters, and the special characters are converted into something bigger, and so the total length gets too big. There's a lot of these. Another one I mentioned is Offbyone vulnerabilities. It's very easy in C when trying to do something 10 times to actually do it 11 or 9 times. And the problem with strings is they have that null terminator at the end that's only 1 byte. And if you're somehow off by 1 and you don't store the null terminator, then your string is an arbitrary length that includes a bunch of bytes that were not supposed to be in the string. And now you can read and write to memory that you were not supposed to be able to read and write to. So there's many of these. So here's one. If you have an if statement here, if certain lengths have a certain condition, and then you got another if statement up there. And if both of those ifs are true, then you end up allocating the wrong amount of space for the string. So memcopy now writes a null off the end of a string. And so again, you're writing into the next variable's data. Here's OpenBSD. If you have a quote, this is a fundamental issue, which one fundamental stupidity in computers is where you take a server and you take data that was created by a different server and you feed it in, and the new server treats it as command line from the user. So now we're going to find matching quotes and stuff. This is just asking for it. And that's what happened here. So they got quotes, but they don't want to have hanging quotes. So if you have a quote, they add another quote at the end to double quote it off, which is fine, but they forgot that that makes it longer. So the extra quote might overwrite the null byte, and now your string doesn't have a null terminator, and that's really bad. So string ncat, for some reason, the C functions never seem to handle this null terminator in any obvious or clear way, so many people are really not sure whether they have to leave room for the null terminator or whether the function really put it there. String ncat always terminates it, and that means you're supposed to know to only write n-1 bytes because it's going to add one more to put in the null terminator. But you know, and they'll say you didn't read the manual. I guess you could take that attitude, but the fact is it's confusing and people get it wrong a lot. If you don't terminate a string with a null, then see when you refer to the string, it will just take all the bytes from the start of that up to a null, however far that is. So now you're reading stuff that was for a different purpose and in writing to stuff that was for a different purpose. So maybe you can just write right in there and write right over the return pointer or anything else. String ncopy is even more fun. Rather than writing off the end of the string like the other string copy function, this one will just not terminate it if there's not enough room. Gee, thanks a lot. Both of those are really rotten things to do. You know, if I was writing it, I would not do either of those things. But they do, and you're just supposed to know that. So here's an example. Since I have 2 buffers exactly the same size, 256 and 256, then when I do string ncopy of that, it won't put a null terminator in it because there's not room for it. So now when I copy it into another buffer, I'm copying something of God knows what size because it didn't have a null terminator. So it's the 256 bytes I wanted, plus as many more bytes after that as it takes to hit the next null, putting it in the next place. So, you know, you could fix it by putting in the null terminator explicitly, and that would be better, but you will lose the last byte of that original thing. You know, this is, you know, if it would seem to me like when you define a string variable type, you ought to have defined the string variable type. So a string 10 characters long can hold 10 characters, and internally there's another null at the end put in by the system and maintained by the system that I don't have to put there. That would have been a lot better. And then you'd have a language like Visual Basic or Java where this stuff doesn't happen to you. But it also means you're not absolutely controlling every single byte as you go ahead, which is what these guys are thinking of. It's clear that the people who developed C were only a small step away from people who just wanted to write assembler. They wanted to have complete control over every bit and every instruction. And they're willing to have a lot of stuff be manual that in retrospect probably should have been automatic. Anyway, I think in the original early version, there was no string library. I think string library was sort of kludged in later. Anyway, but I'm not sure of that. Anyway, that's the game you can. Now here's another fun thing. If you don't process data in your loop 1 byte at a time, but you skip ahead by 2 or 3 bytes under certain conditions, then you could skip over the null terminator and continue processing stuff beyond what should have been the end of the string. That's why this whole idea of having a null terminator byte is pretty problematic. It might have been better to stick with the Python rule and just have the length in the first byte so you always know how long things are instead of hunting for this terminator that might not be there. But anyway, that ship has sailed. This is what we got. So Apache, for example, if you have http://yahoo.com, well, it's got this irritating : So you have special code just to skip past the : and jump ahead by 3. Now that would be fine, except not everything that Apache processes has a : Here's a list of the handlers. There's HTTP and HTTPS, but then there's LDAP and news and mail_to that don't have the //. So you can send LDAP:(A), and it will skip past the A, thinking it's got to be a //. And so stuff that is outside your string will be treated as part of the string. And again, you've got the ability to refer to memory that the programmer did not expect you to refer to. Then there's signed comparison. Boy, there's an endless list of these. There was somebody that had somebody in one of my, I think my 125 class, a student gave an extra credit project, and he showed horrible things in JavaScript that just make you cry. You can set A = 1, set B = A, and set C = B, and suddenly C doesn't equal A. It's just mind-boggling. You can do horrible things, and it all comes from conversions. If you set A = hello in quotes, and then A = 1, those are 2 different data types. And most languages, now if you want to be really strict, you would just always force you to explicitly state, this is an integer, this is a string, this is a character, this is double precision, like C does generally. But a lot of languages let you get it be, they call it weak typing. It will guess what type you mean. If it's letters, it'll figure it must be a string. If it's numbers, it'll figure it has to be a number, and it will guess how big a number and whether it's floating point or not. And of course, it can get confused. So if you do compare 2 data objects that are not the same type, then it will often do something ridiculous. So here's one thing that happened here. Apparently, you can even do this in C, which is news to me. You can take integer and another integer and compare them and add them and subtract them when they're not exactly the same type of integer, which I would have thought C would not let you do that. It would just say, I'm sorry, you cannot add a signed integer to an unsigned integer. Go away. But no, it won't do that. It will silently typecast one type to be like the other type and then add them up, which is really bad. So here's an example. It turns out that buffer size is a signed integer, and it came from the user, I think. Oh, remaining is signed, and that came from the request. So if I feed in a negative number in my request, it will accept that as unsigned, translate it to signed, and then not understand this. And so the attempt to limit my length will fail because of the, there's a lot of these. There's one in the 123 class I've added where you go to a smart contract in Ethereum and you trick it into subtracting 1 from your wallet when your wallet has 0 money, and it rolls around and you end up with an infinite amount of money because it rolls around to some enormous number. The same kind of trick. So there's integer conversions, so you can take -1 in 16-bit signed, but if you put it in unsigned, it's now this monstrous number. Like I was saying, underflow going from 0 to -1 will turn into the largest possible number in an unsigned variable, and so on. As you convert from one number to another, bizarre things happen. So in a careful language, I would just think you would not let anyone compare any variable except to another variable of exactly the same type. But that's not what happens. It guesses and converts and then has unexpected results. This one was pretty funny too. You hash passwords typically, hash them with something like MD5 or SHA-1 or SHA-2, and then you store that. Well, that's generally all right, but the problem here is you compare the hash. If password equals this, now if you compare it in PHP, PHP is a weak typing language. So when you compare the password, It is possible, although very rare, that your hash will have this format, 0E and then only numbers but no letters. Now, if it has that, this will be interpreted not as text, but as a number, because 0E is the shorthand for taking 10 to a power. So this is 0 times 10 to the 123 trillion, which is 0. The number 0. So all such numbers are equal to each other. So if your password happens to be any of the infinite number of passwords that have a pattern like that, it'll be equal to a password I can create that has that value, and I can log into your account with the wrong password. That's a password hash collision, and there have been a lot of these. There are some CTFs that have these. For example, some of the old BIOSes, I don't know if they still do this. If you have a BIOS password and you put in the wrong one, it'll pop out a box saying, error code X473. That's a code, and you can use that to generate the BIOS password. And BIOS passwords are sometimes stored with something as simple as like a CRC32 hash. So there really only are 4 billion of them. So you can generate passwords that happen to have the same hash, even though it's not the right password, and get in. Anyway, that's the kind of thing where a string is reinterpreted as a number by the code, and you don't know that. By the way, the solution is to have 3 equals. 3 equals is what you do in PHP to say, I want it to exactly agree in value and data type. And if you'd asked me, it should always be that way in the first place, but it's not. All right, and then there's double free. This is another thing. It's certainly quite understandable how this would happen. If you think about this whole process of dynamic memory allocation, it's asking for trouble. I'm not going to declare a variable with like room for 100 characters and use it. No, I'm going to declare a variable when I need to store something, make it as big as it needs to be, and then later on I'll let go to give that memory back. Now, this is good to avoid wasting RAM, but it means I had to decide how much room to store, and I had to decide when I was done using a variable and decide when to give it back. And that's just asking for it, because it's very easy that you somehow allocate it and then free it, but some other part of the program doesn't know you've already freed it, and so you try to free it twice, or you allocate it and somehow forget to free it, and that's a memory leak. There's many ways for it to go wrong, since you have 2 things that really should always go together. I allocate it and I free it, but they're separated in your program. It's entirely possible that it will not work the way it must work, which is 1 allocation followed by 1 free, 1 allocation followed by 1 free. They ought to be like brackets where they're matched, but the structure of the code does not enforce that, and you can easily make a mistake. So the best practice is this: whenever you free it, immediately set it to null, so that even if there somehow is another copy of it somewhere, it can't be used because it points to an invalid address. That would be a good practice, and that, if you ask me, they should build that into the compiler or something and just automatically do that. But they haven't. So you can declare memory regions, these 3, and then you decide you're done with this one and delete it. But there's another pointer to the same object. That pointer has been copied by something that's still hanging around. That's what I said. The #1 vulnerability now for Windows as of 2013 is dangling pointers. This mistake means that there is something I can write to that is no longer being used and probably being reused for some other purpose. Now I can write some data which will be misunderstood, and it might lead to code execution or any variety of usual stuff. So you can also have uninitialized variable usage, and this is essentially what happened with Heartbleed. You, in the data and the stack segment, when you start the program, the operating system nulls it as it launches you. But for some reason, it does not do that. And data and BSS checking, it doesn't do it on the stack and the heap. If you use uninitialized memory in the stack or the heap, it contains leftover stuff from before, and that might be important stuff. And that's what happened with Heartbleed. You would send it a packet saying, I'm sending you 64 kilobytes of data, which you'd echo back to me, but I only send 10 bytes. It will just send me 64 kilobytes of what happened to be on the stack, which is left over from the last user, and might contain their password or the encryption key for the server, or any weird thing just hanging around in memory. And that's the game here. Uninitialized variables aren't just 0, they contain whatever's left in them. This was true of Amazon EC2. When Amazon EC2 came out, maybe 80 years ago, when they started having these virtual machines, you could rent a cloud machine, and somebody quickly, some security-oriented person, rented a cloud machine, put Linux on it, and did DD to see what was on the hard drive, and it was all full of the data from the last user. They were not wiping the virtual machines before creating a new virtual machine. I think they fixed that since, but this happens over and over. Data remnants. People have computers they donate to schools and give to recycling, and USB sticks and copiers they rent and copy things and then pass it on to the next person. And most of those things have the data still stuck in them, and you can find it. It's a common source of data leakage, just like lost laptops are. So anyway, uninitialized variable usage, if you actually use a variable to do something and you never initialize it, that's pretty screwy. Usually it'll crash, but you might find it in code that's very rarely used. There was one that came out about 3 years ago. It turned out that the virtual machine software used for most of the cloud providers was Kinu, I think. And it turned out that the floppy driver in the virtual machines had a simple buffer overflow, the type we've done in this class, and nobody noticed because who even thinks about the virtual floppy on a cloud machine? There's no way to connect to it. It's just a useless appendix, but it is included by default, though, as virtual machines, and has code nobody's looked at in 20 years, and it's got a bug in it. So that's where you'll often find it. So if the data is null, here I've got if data, then allocate something. If something is here, then free it. And in any case, you better free it. So this means under certain conditions, it will not create it because this condition is not true, but then it will still free it. And as we know, freeing something that doesn't exist is dangerous. It leads to a write. So what it means is the free operation is going to happen for something that was not correctly set. It's going to have random data in it left over for something else. That might be something that was under my control. The data in that might have come from some previous data from the user, and now I've got a free operation on data I control. We know how to take over the machine with that, because that means I can do a write operation. I can control the address written to and the data written to it, so I can write something like a return pointer or a global offset table entry. And so this is used after free. You allocate a heap buffer with malloc, you release it with free, but I could have had another pointer to the same object created, and that would be left over, so now I can write to RAM. And if I can write to RAM, I can make arbitrary code execution if I can hit an interesting part of RAM, like a return pointer. Another big issue is multi-threaded code. I've tried writing this a few times. Multi-threaded code is no joke. It means each new user creates a new instance of your program that's running. And now if your program used any kind of temporary memory segment, like one common thing people do is make temp files in the temp folder, then the other thread coming from another user running the same code might use that same stored data and overwrite it. If you're going to have multiple users sharing the same data, you have to have a locking system where the first one locks it, and when the next person tries to use it, it says, oh no, you can't use this one. You have to wait until I'm done using it. And this is actually quite common because the problem is you can write code and test it and it's fine. This has happened to me quite a few times in 140. I write a project, it works fine. But when I actually have like 6 people doing it on different machines at the same time, now it doesn't work anymore because it's more complicated. And this is the kind of thing that will only matter when you have so many users that 2 of them are actually doing the same thing at the same time. So it might even be fine with 100 users, but not 1 million. So it happens. There's some good examples in the web application Hackers Handbook we'll be doing next semester where this happens to banks. They write code which works fine until you really have it in production, until it really becomes popular, and now people's money are going in the wrong account and seeing each other's balances and stuff. Because the assumption that you can write something and then read it a millisecond later and it'll be okay is fine until you reach a certain volume of use. There was a couple vulnerabilities of this I heard, like about 5 years ago, there were people that said, wait a minute, I opened my Gmail and it was somebody else's Gmail. And then, wait, it didn't happen again. I'm not insane, it really happened. And I said, yeah, that kind of stuff does really happen. And sometimes it happens real rarely, and they may or may not ever really get to the bottom of it. Anyway, so we got some cahoots. And they should be open in a tab here, maybe not. All right, I'll open them again. All right, it should be in the favorites. And there we are, source code auditing, okay. And I should be able to play the glorious Kahoot music. Oh, good, sounds like music plays, or music plays through these fancy speakers in this room. Maybe it's the speaker. I think they've upgraded to music. Maybe we can just hear it better. Christmas, actually, I got Christmas bells in it. You're right, okay. Logo. Oh, yeah, yeah. It's like Google Doodle, yeah. Our AV in these classrooms is much better than it's ever been. All right, I'll give it a few more seconds. I see Maribel is connecting remotely with Charlie. I'll give it a few more. Oh, here comes a chat message. Reggae music, yep, that's right. All right, let's try it. So which one will expose data from the stack? All right, format strings, we've been there. Format strings typically just print out data from the stack. That's the main thing you get is stack information disclosure from them. All right, which one do you get by using stir copy? That's a classic buffer overflow. It copies one object into another without checking the length, so you can override the buffer. All right. Which vulnerability is likely if you have multiple pointers to an object? All right, you might have double free. You might free it and then accidentally free it again. All right. Which one is likely if you process several bytes at a time? Right, you might jump past the null. All right, if one part of the program corrupts another part's data, what have you got? Yeah, talking about multi-threading, that might not be the best description of it, but I think anyway, I would say one instance of the program is treading on another. It might be the same part. Anyway, all right, comparing one data type to another, what have you got? All right, integer conversions can get you in big trouble. All right, so are you Ojai? Okay, good. And M dot, I know who that is, and I know who Caitlin is. All right. All right, good. So I know who won, and I think that's about it. Let me just see if there's anything to say about the projects. I think you already know about the projects. The only new stuff I've added recently have been these memory protection ones. We talked about them. There is one with source code analysis. If you want to do it, it's mostly just pretty disappointing. Really much convinces me that this product is not going to save you. Flaw Finder might, I don't know, man. Like so many things in security, it's pretty disturbing. Anyway, there is the ARM overflow, which is good, clean fun. If you haven't done that, that's probably worth checking out because ARM is the future. Intel's on the way out and ARM's coming in. That's what they say. And so you might as well take a look at ARM assembly code. You'll find that once you know one kind of assembly, the rest is pretty much just more of the same. But there are minor differences. All right, let me see. I had a chat message coming in. For the 128 mobile hacking, will I get an ARM assembly? Probably not. We haven't in the past. It was mostly Android at the Java level. However, I've been interested in like rough overflows and exploits directly in Android, like kernel exploits in Android. It would be good to add them in. By the way, another thing missing from this course that would be good to add is direct kernel exploits in this class. We haven't done them. So those would be possible improvements.
In 128, it's going to be mainly Android?
Yes, mainly Android, because iOS is now so secure, there are no public jailbreaks. So the only way you can do any iOS code auditing is first just at the black box level. We're going to do that, where you look at the network traffic and such, or you have to use a really old phone, like 8 years old. And those things are so old, most apps won't run on them anymore. So it really is of minimal importance. That's why, you know, That's why I say iOS in practice is a whole lot safer to own because it's very hard to hack into these days. But there was an article this week that said that, in fact, there are a bunch of jailbreaks in the latest version of iOS. It's just that they now cost $3 million on the open market. But apparently so many malware developing companies have begun to sell them that they're leaking out. Not only just nation states are using it, people are selling them. And they say pretty soon they're leaking out. It's becoming pretty common that there's commercial iOS malware using these unauthorized jailbreaks. So it may leak out in the jailbreak community again. Until a few years ago, there was a vigorous jailbreak community that could totally get in and get you root access to your phone, and then you could get in the apps and do all this stuff. And without the ability to do that, it becomes very hard to do any exploits or really test the security of the phone, which is one way to say it, is it's so secure, you don't need to worry about people doing this stuff, but except for the people who can afford to pay $3 million to get the break. But, anyway, at the moment, I can't give you any projects we're doing on iOS, really. We'll do a few simple things, but we can't get deeply into it. The only system we can really get into is Android. And that's not because Android is vulnerable, it's because Android is open. It is part of Google's intention that if you want to root your Android device, that's available. They don't want to lock you out of rooting it, and that's why a whole lot of things are visible. Maybe they could change their mind about that, but they are an open source thing, so they have this philosophy that you should be able to get full control of your device, and that means you can hack it and we can play with it. Any other questions? Oh, I should mention, in case anybody doesn't already know, if you're trying to register, you're pretty much hosed. If you're trying to add classes, the website is completely screwed up.
So I tried to add CNIT 50 yesterday.
Yeah.
There's the problem with the wait list. And
Yep.
I was actually at the administration building, and they were able to put me on the wait list from there. However, they said that they're going to let someone else know whoever's responsible for that.
They did contact.
Your class, there's other classes that are similar.
Yeah, they did contact someone in the department chair. Right, 1 of 2 seats remain, 4 of 10 wait. That's what I thought. But see, they're trying to tell him that the fact that the other thing they don't tell you to only meet 6 times. They don't have the dates here. They said, oh, we didn't have the dates. That's why it doesn't work. And I said, well, that's another problem, but that doesn't explain why with a cap of 35, only 2 people can get in. That's not an issue of the dates. But they told our department chair to let's and they're off doing that. But anyway, but this thing is, and apparently it's not just this obvious problem, but there are other problems. So a lot of people can't get into classes. So they tell me they're getting flooded with people just trying to do it on paper. I don't know what's going to happen. It's a real boondoggle. Yeah.
But so the CNIT just show up the first day?
For my classes, just show up the first day, and I'll certainly let you attend the class and learn the stuff. As far as getting credit, though, you have to somehow make it through the bureaucracy here, and God have mercy on you.
Also,
Yeah.
one thing they mentioned yesterday is if you are one of the list people to be waitlisted right now,
Yeah.
Apparently once the issue is solved, they're going to send you an email, and you have about 24 to 48 hours to enroll in the class.
Yeah, well, that's true. But I've never had to throw anybody out in years, especially now that my classes are available remotely, so I don't really even need a big room. So as far as I'm concerned, everybody can get in. But if you need credit, then you do have to deal with those guys. And as far as I know, it's pretty hopeless getting sense of it. So last night I got as far as getting prompts, had to wait till late December. Yeah. So if you're trying to officially enroll, I don't have a good answer, and I don't anticipate a good answer coming from them. I wouldn't be surprised if the next semester is going to start and we're still going to have a website that doesn't work at all and no real guidance what to do about it. I know what they typically do here, they've done it to me for the last 3 years, is every time I teach a 1-credit course, they make the deadline to add before the first day and tell all the students they're late and don't let them know. That is very common. And that seems to be more common than not. This semester I had 35 students try to add my 1-unit class, and they only let 5 of them in, just because they lost all the paper and stuff. So, this is part of the value of a college education, is that you gain experience dealing with a totally hostile, cruel, incompetent bureaucracy, which is really valuable in a job, because whatever job you go to, there's going to be some of this nonsense going on. You develop the ability of tolerating abuse. Yeah.
You said in one of the other classes this week that the network security monitoring class is going to be all Splunk.
It is. It's going to be Splunk certification, yes. Last time I did open source tools, and the lesson I learned from that is to hell with it, just use Splunk, which is, I think, what everybody else figured out, and that's why Splunk is rolling in the dough.
And you also mentioned that the forensics class was going to start being more end-case focused.
I think so.
When is that going to be, this semester or later?
Probably later, okay. But you have to talk to Alan Winterston. I know he's going to go get certification, and we're going to get the money, but it's not going to be next semester. I think it'll be later. But yes, I did in the same spirit. I think both of our classes, we finally got tired of beating our head against the open source stuff, and the industry has settled on paying for expensive solutions, and so we're just following them. That's what people really use. They will really hire you because you know Splunk. So you might as well just go join the bandwagon.
So
Yeah.
your class is going to prepare people to get a Splunk certification?
Yeah.
Which class is that?
CNIT 50, Network Security Monitoring. Yeah. The one you can't add, but anyway, I'm going to just follow the Splunk program. I'm probably even just going to use the official Splunk training materials instead of a textbook, because the textbooks are miserable and the training materials are very good. So it's just going to be like Cisco or like Microsoft. I'm just going to follow the official program. I think that's the best thing to do.
Which Splunk training are you using?
There's a free one. I'll have links. I've got links already on that page. Yeah, the first one. It's only going to do the first search. There's like 4 Splunk certs, and I'm only doing the first one, the user search. There's user, power user, administrator, and architect, just like there are Microsoft certs. In a 1-unit class, I think getting to the first cert is sufficient. Although the others, I'm sure, are also valuable at getting jobs and stuff. But my only goal in this class is to get students to the first one.
Is it free to get the cert on your own? Or?
It is free to take the class on your own, but I think taking the cert test costs like $140. I'll know soon. I'm planning to take that cert quite soon. I'm nearly done with the class. But it's all review for me because I used to be a database analyst. And all Splunk is SQL with a few extra things. All their features are just their version of how you did it in SQL, so which is fine. I'm glad they didn't reinvent the wheel, really. I mean, SQL had been the answer for 20 years of how to search through databases, and they're just using SQL with just a few little alterations to fit their product.
So do you need to know SQL before you get the...
No. They'll teach, you can learn how to use Splunk, but if you do know how to use SQL, you'll find that Splunk is pretty much the same. And I suppose if you learn Splunk, you can go learn SQL pretty easily after that. It's very similar. Mostly it's just standard SQL with a slightly different name. It's like the difference between... Well, it's a 1-unit course, so it only meets 6 times. Yeah, if it was a whole semester, we'd probably get to a later Splunk certification, and that might be a way to go. That might be some course in the future, but I'll start with this one, and then we'll consider how much to go in the future. There's so many industry products or certifications, we can't do them all. Like I know we were talking about doing Salesforce certification in conjunction with the business department and stuff, and that's probably a good one too, but there are tons of them. And you have to pick them carefully. I think the firewalls class should be Palo Alto certification, and the forensics class should be NCASE certification, but I'm not teaching them, so I've been influencing from the outside with limited success there, but that's...
Will the college pay for our certs if we take this class?
Generally not, but in this case they might. They now have a program. Steve Nelson has a program to pay for some certs. He might. You got to talk to him. He has some money. It's not a lot, but you might be able to get in and pay for your cert. It's not impossible. Hey there. All right. Well, I'm going to stop the share, and I'll go down to the lab and help people. I know some people need help today. All right. And I saw a chat come in. Last night I got it looks like same thing I saw already. Okay, thanks. Good. Okay, we're going to end.